hint when we were talking the other day, since obviously we have an abbreviated amount of time today. It's not a full class, okay? So chapter 1 was how software and hardware work together. That's the overview of the entire course. We talked about the input and output devices in the class, and I am recording to push this up as well. Talked about the primary devices that we've got right now that we've talked about. We've talked about the motherboard, the CPU, and the CPU chipset so far, and we're going to get more in depth as we go. And the components that we've gone over really just right now is the motherboard and the electrical system, right? So the motherboard primarily provides a way for everything to talk to the CPU. We already talked about this, primary input-output devices, although some people got this wrong. We know what PS2 looks like. Keyboard's usually green. Mouse is usually green, keyboard's usually purple, and that's true 99% of the time. You guys already know how to hook up a PC. You know that you always use the expansion cards over the integrated components because the motherboard assumes if you put in an expansion card, you want to use it. So these always override those. So if you were to set up a PC, we know that we always set up using that video card over the other one. Input and output devices, those are our primary output devices as well. Things inside the case. I don't even like this review. And there we go. Okay. So we should be able to identify those things that are inside the case. And you know what? I don't even like this slide. I should look for this one better. I made it last year, but it doesn't. I must not have liked it last year either. Because I want to get right to power where we were last time. Man, I might as well go through the slides anyways. So, what is my projector doing? I just had an HDMI cable go out in another room, and I'm just wondering if this one is going out in this room, because it's acting really funny. That would really stink if I put in all HDMI cables and they all start lasting 2 weeks. That would really stink. Okay, we should be able to identify all these things on the motherboard. We went over this last time, but CPU socket, that is for what manufacturer of CPU? What? Intel, we can tell because of the hook on there, so it's an LGA slot. We've got a regular power connector, we've got an extra power connector. That is a what volt? 12 volt, right? And this one is 3.3, okay? Then we've got our SATA connector, our IDE or ATA or PATA. It's actually, we always used to call this ATA until serial ATA came along. Oh my gosh, this is going to drive me crazy. We've got our PCIe extended slot for our video card. That's either a X8 or an X16. We've got our regular PCI slots. We've got our PCI X1 slots back there as well. I should be able to identify all those things. I should be able to identify what plugs into these things. I should be able to identify USB. I should know an RJ45 port is a network port. I should be able to identify what the sound out microphone and sound in look like and what color they are. Speakers always plug into green, microphones always plug into pink, and the blues and the extra sound input spot where you usually plug in stuff like your stereo and stuff. And there's our line in, there's our regular line out for our speakers, usually our microphone port. And if we've got 7.1 or better, we've got spots for subwoofer, rear speakers, and our side channel speakers as well. There's our RGA 45 network ports, and then our PS2 ports up there. Okay, so a CPU is our brains to the operation. The chipset is what controls the flow of information to that. Without the chipset, the CPU is worthless. Okay, it controls all the flow of information around the motherboard to the CPU. And let's picture the chipsets on the motherboard. We know that the north chipset controls communications from the CPU to the RAM, the video card. The south bridge controls everything else. This is a really old, that's a Pentium 2 vertical board that doesn't even have a heatsink on it. But on the chipset, if it's the bigger heatsink is always on the north bridge than the smaller one if I was to ask you to identify. Difference between temporary and permanent storage devices and primary and secondary. Memory is primary, but it's temporary. Hard drives, and this is not my drawing, hard drives, flash drives, CD-ROMs are secondary, but they are permanent. So you should be able to put those two things together in a matching type question. Primary means primary to the CPU. Okay, different kinds of RAM that we look at. We'll look at more of that chapter 5. And then also there's primary storage on the CPU itself, and we know about that now because that is our cache, which is the memory that is right on the CPU or comes with the CPU. Secondary storage is permanent, but it's secondary to the CPU because it doesn't access it directly, and that's CDs, hard drives, floppy disks, flash drives, anything that's permanent you can consider to be secondary storage. Two kinds of connectors for our secondary storage devices. The older ribbon cable is PATA or IDE, or sometimes just called ATA, because the newer one came around and it was serial instead of parallel, and that's what SATA is. So we know the ribbon cable is PATA, the mouse is not ribbon, so it's crazy. And then the newer single connector wires, these kind of connectors right here, are SATA, and we know that those are a minimum of 2.5 times faster, but it can be far faster than that in the older type of connection. All secondary devices require power, and the power usually on any kind of a spinny drive has a separate power connection, and those are always what voltage. This power connector right here is what volt. If you don't know, it's 12, right? So it's 12. Did you know, Levi? So it's 12. If you have to guess, it's 12. Okay? What's the only thing that ever says 5? Floppy drive. Okay? So if I don't tell you it's a 12-volt connector, whether it's one of these older Molex connector or the newer, I think I have a picture now of, or the newer connector that is a SATA power connector, it's on the desk. Doesn't matter, they're still 12 volts. The bus is how the data goes around between the individual items in the CPU, and the width of the bus right now can either be 32 or 64-bit. Newer is 64-bit, but most things are still 32-bit, and it travels around at a speed determined by the system clock. Okay, the clock starts pulsing. That was the number 2 thing that happens when we push our button and turn on our PC. The system clock starts to generate clock pulses, and the information all moves around at the speed that the system clock generates clock pulses. And everything terminates at the CPU because everything's trying to talk to the CPU on the underside of the bus. And that's what the system clock used to look like. It's actually much smaller than that. We should be able to identify our slots. I should be able to readily look at this and match up what's PCI, what's PCI 1, and what's PCI 16 or 8 looks exactly the same, but I won't try to trick you on that one, obviously. So, but older PCI, PCIe is everything else that has the notch up front here. See the difference between the notches at the back of the motherboard actually versus the middle of the motherboard on the PCI slot. Interface or expansion cards are those things that we can add to a motherboard to add capability to the motherboard itself, and they just slide right in the slots. And then we have to add what to make them work. We put it in physically, and then what do we have to install to make it work? Drivers, right? Drivers are programs that make hardware work. If I put in that device but don't install the drivers, it doesn't do anything. It will not work. Electrical system converts AC to DC, and it is at 3.3, which is the main one, 5, which is one of the voltages it outputs, and then 12. Most of the connectors are 12-volt connectors. The motherboard is 3.3. We have system fans in the PC running to keep the temperature below 185 degrees. 185 degrees is the temperature at which components fail. Temperature at which electrical components fail. And that's a typical power supply, and we're going to talk a little bit about power calculations. I'm going to go off right now, and we're going to talk a little bit about power, because that's where we actually got last class. Let's see if I can find that picture that I had just. Did I make it on this one? You're going to see on this one, the ones you calculate, the chart looks like this instead. Okay, so instead of the way I had it before, where I give you roundhouse numbers for dual core, quad core, 6 core, it's not going to give you any wattage for the CPU because we've done CPUs now. So now you have to find it on your own. I'm still giving you a flat number for the motherboard, so you don't have to look up two things because motherboard powers are generally the same. Okay. But the CPU you have to look up, and then the chart provides everything else. This chart is actually the one that's going to be in the final. 30 watts for the integrated video card. If it's a add-in video card, but it's not specifically a gamer, we're calling it 50. And if we're saying it's a gamer, we're saying 120. Realizing that some gamer cards you're going to find when we get to the video card section actually use more than that. Same thing we had before. You're going to find out how many sticks there are. 15 watts per stick. Optical drive, roundhouse 30 watts, hard drive is 25, floppy drive we're saying is 5. Any other expansion cards, 5 watts. Any USB that you know you're using with that system. In other words, it says it uses a USB keyboard and mouse, then you're going to add 6. If it doesn't list anything, then you're not. Realizing, for your own personal edification, that if you're trying to figure out for home and Dylan knows that he's going to have an external hard drive and I'm going to have a scanner and I'm going to have whatever, that at home you would add those other things to. Here you're just going to assume whatever comes with it. And then any extra cooling fans you're going to add 3 watts as well. So you're going to go through and do that on the final. And it's going to work. I'm going to go ahead and pop to one. In fact, I'll go as far as going back to our electrical system one and using one of these randomly chosen. Let's see if I use this one. So if I gave you this one, which is not the one I needed, and I wanted to find out, I would need to find this CPU, and I have no idea whether this one lists the wattage or not. We'll assume it does. As we go, I did make sure that the one I needed. So we'll just see. I want to go to the actual CPU site to try to find if it lists the wattage, and right there, boom, 45 watts. Okay, so if I'm doing this one, I need to go to the actual link that I'm giving you for the system, and then when I read about the system, I need to go and research the CPU. Does that make sense to everybody? Okay, so I'm not giving you roundhouse numbers. You're actually going to go there, look it up, find what the wattage of that CPU is, and plug that back into your chart. So if we were doing that one, did I close that? So if I was doing this one, I would want to say I got 50 watts plus 45 for the CPU, plus it's got integrated for 30, plus it's got 2 sticks of RAM for another 30, plus it's got an optical drive, it's got a hard drive, no floppy drive, no expansion cards, no USB, whatever, and then total that together. And then I'm going to either ask you calculated or minimum or recommended, just to make sure we understand that again. Just put down my pen real quick. If we came up with 235, that would be the calculated number, right? And then what would be the minimum number? 250, because I round up to the next 50. And the recommended would be 300, okay? I'm going to ask you one of those. Or I may give you one and ask you another one. On one of them, I may say the calculated I came up with is 235. Does this, and give you a link to a power supply and say, does this meet the recommended settings, which means you would need to have 300 or more to meet my recommended requirements for that particular one. Okay, but that's the only difference in your calculations over what you did in Chapter 3. It's going to say CPU as researched on the question on the final exam. If you read my email, there's 54 questions in the final exam. I actually whittled a bunch off to give you more time to do calculations. But you do not have time to look up everything. You do have to study for the final exam. You do have to make sure stuff is in your notes and you are familiar with your own notes. Frequently students come to the final exam and say, it's in my notes, and they're going like this and they don't know where it is in their notes. Okay? So notes, anything you have in your notebook is free game. If it has to be written in your handwriting, no copies, no printouts, anything like that, as far as notes go. And you will have to know some of them, or at least know where they are readily in your stuff, so you can find it, so you're not hunting around in your own notes to find stuff. Okay, the BIOS exists. We talked about this last class. The BIOS exists on a CMOS ROM chip. Okay, the configuration is on a CMOS RAM chip, and I wanted to go through it again. The startup instructions: we push the power button. It actually before this step number 1 happens, we push the power button. It does a self check on the power, so it runs a power, and then it does the power on self test, where it goes around and checks the motherboard components. And before those two things happen, I push the power. It checks for good power. It starts the system clock, and then things start running. BIOS loads, runs a power on self test, loads the configuration from CMOS RAM to look where it's supposed to find the operating system, hands-off control of the operating system, which starts itself up, loads its own drivers, and then comes up to the GUI. And I'll just set that. I didn't say test for battery failure, but it will give you an indication if you get a battery failure, and it's the CMOS battery that holds information in the CMOS RAM. We didn't even go over this on the actual location of the boot record, but it's on the RAM on the CMOS chip. Is where BIOS saves the configuration start data. Operating system provides our GUI. It's what runs our applications. It's our interface. Our GUI stands for graphical user interface, and we went over the different distributions of operating systems that are out there. And we already said this: device drivers are small programs that make hardware work. That's the pieces of what you need to know. If I don't have the driver, I can download it. It might come with floppy anymore, obviously. CD-ROM is how it usually comes, or you have to go online and find the device driver on your own. Form factors we already talked about, describes the size, shape. We are using ATX primarily in this class, knowing that BTX is pretty much compatible except for the motherboard itself. We've got a lot of BTX stuff in the district. The other ones are not compatible very well with the different things that we've got out there. We have to make sure that the motherboard fits the case, and the power supply provides the correct voltages, and the holes in the motherboard line up with the case, or all those things will go together to build our nice one. And we've said that normally we use ATX, and then we've got some BTX here at the school as well. I'm not going to ask you the size and dimensions. We already went over this. You need to be able to readily identify these things on this picture. In fact, is this one of the pictures? I don't think I used this next picture. What's this right here? Northbridge, and this is the Southbridge, and there's my SATA connector, or my PATA connector, my regular PCI. Okay, hopefully that's the easy part of the test for you guys. And you might want to look over the old one. I think this actually is a picture I used in the test. What CPU manufacturer is this for? AMD. How can I tell? It has holes and it has no hook. Okay, if it's got holes, it means it is a PGA or PGA socket for pin grid array. It's also a ZIF socket is the other way to call this one. And there's my Northbridge. There's my Southbridge. How many video cards can I put in here? What? How many video cards? How many PCI X16 video cards can I put in here? What? 2. Okay. I'm going to ask you a question like that. You need to be able to identify the ones with the little latches. It's kind of weird that it has different latches in the 2 video cards, but those are the 2 video card slots. There's my 3 regular PCI and my 2 PCIe. There's going to be a matching one, not with this motherboard, asking you how many of each kind of things there are. I think you had one like that on the other chapter test. My power connector, we know that AC is the most efficient way to transmit electricity, but DC is what We have an electrical devices, we have a transformer rectifier that changes it from AC to DC and then changes it to those various voltages that we have inside of our PC. We already went over this last class, and the difference between volts, amps, and wattages. I don't talk about ohms and resistances, that's really not that important when we talk about our power supplies. So, when you evaluate power supplies, some of them talk about what the resistance of the different rails are, but I don't think that's important enough for you guys to work on. So, we need to know voltage is potential, amperage is current, and wattage, which is total power, is voltage times amperage. So, if I gave you one of these and said what the component was and asked what the wattage is, you should be able to figure it out because you've got heard enough of the answer and most of it should be in place. I should remember from chapter 3 what surge suppressors, power conditioners, and UPSs are for, and what the different power conditions are. Surge suppressors only protect against spikes, momentary increases in power. Power conditioners protect against spikes and brownouts as well, and the UPSs protect against all three of those. So if I had to match, that's the way I'd match them. The third one being the blackout, the UPS is the only one that protects against the blackout. And a smart UPS is one that communicates with your PC and tells it that it's out of power and it needs to shut down. Almost all UPSs now are smart UPSs. I haven't seen one that isn't a smart UPS anymore. Remember back from chapter 3, static electricity, we should have in our notes what the static electricity is to feel, hear, and see. You guys remember what those voltages are? From our notes, I should see in there that in order to feel it, it has to discharge at least 3,000. In order to hear it, it has to be at least 6,000. In order to see the spark, it has to be at least 8,000. So if I said you could discharge X amount of voltage without even knowing it, it'd be up to 3,000, right? So as soon as it's over 3,000, then you would know it. You'd be able to feel it. Obviously, you can. And here you can feel it and hear it. Here you can feel it, hear it, and see it. So, and that's when voltage potential charge is exchanged between different objects. That's why you walk around with your feet on the carpet, build up a static charge, and you shock your little sister. So you're just equalizing the charge between the two. Different ways that we protect ourselves with wrist straps. We use anti-static bags, and we've talked about it extensively here. Make sure we're unplugged. We hold down the power button for 20 seconds, and then we always touch the power supply before we get inside a PC. That's how we do it here. We can use the AM radio to detect electromagnetic interference, and shielding of cables is what protects from EMI. We just got done removing all of these because I think what we've got is an EMI problem. All these electrical lights create electromagnetic interference, and these Belkin cables that we had aren't shielded well enough, so you'll get all these distorted pictures and stuff. In fact, what we were seeing in some of the classrooms was a double image where we would see whatever was being projected, and then behind it, there was a gray image of the same thing. And that was because those cables weren't shielded well enough, and they were causing a distortion. So we're throwing those away and putting up nicer cables as we redo with the HDMI on this one. So I should be able to identify what plugs into what from a picture like that, or like that, and say how many volts is that? 3.3, how many volts is that? That? Also 12? Okay, there's our 5, and that one's an old AT motherboard. We can talk about that one. Should even have a picture of that one. Anyway, and that's the stated one that's 12 volts, just like that one's 12 volts, just like that Molex is 12 volts. Those are all 12 volt factors. And I already talked, we're not going to use this one because we're not going to use this particular chart. Now that you guys are farther along, you guys are going to have to research and find that one. Which is part of the reasons I cut out some of the questions so you would have enough time. Some of you guys are going to get done quicker than others, but I want to make sure everybody's got enough time to get it done. It is timed at 75 minutes, so you will be done in 75 minutes. You won't be able to say, I've got 2 more questions left to do. 75 minutes, and we'll grade it, and you'll be finished with the test. If we might have to upgrade our power supply if we add new devices because all of a sudden required more wattage. That's the number one reason why we have to upgrade our power supply, because we added new devices or upgraded our PC. And we talked about how the number one way that or the first indication of a power supply failure is, remember that? First indication of a power supply failure is what? The fan, the lack of air through the back of the power supply, because that's usually the precursor to a power supply going bad. No, isn't that here? Is that fan stops working, it starts overheating. Our second indication of a power supply going bad is our computer not booting or shutting down, because usually it shuts down from it overheating, and that's a normal thing that happens with the power supply. It runs for a while, then shuts itself down. So the first indication is usually lack of airflow from the fan, unless it's like way over wattage, and then it just runs for a little while and shuts down when it overheats, even if the fan is running. Look for odors, connections, loose power cables. Make sure all your switches are on. We're not gonna talk anymore about troubleshooting the switches that go in, because I'm not gonna ask you any questions on those. That's probably far more this one. And we just finished everything on motherboard, so that was the last thing I wanted to go over. First of all, do you guys have any questions on the motherboard? I should look at your survey that you guys did. Is there anything in particular that when we were done, let's see. Did you guys all end up being able to take this once we got all back on? You guys didn't take that? People said they still can't, you know what, that's not going to be this year. Last year too. I'll just go through, we got a couple minutes left. So we've got two manufacturers of CPUs. We've got AMD, we've got Intel. Intel's primarily LGA, the slot with the little hook. AMD is usually primarily PGA. AMD is usually less expensive than Intel, but Intel is still right now the faster of the two. But per dollar, speed per dollar using AMD comes out better if you're restricted in the amount of money that you have, okay? Motherboard determines the kind of CPU, what the chipset is, how many and what kind of expansion slots we have, what kind of memory and how much memory we can put in there, as well as the kind of case that we're going to put it in, whether we can put it in a mini ATX, a full-size ATX, a micro ATX motherboard. All those things are determined by our choice of motherboard. These are all motherboard pictures. Are there any of these that you're looking at that you're like, I don't know what that is on the motherboard? I guess I should stop right here. Have you guys looked at enough motherboards at this point that when you look at them, you know what the different parts are? There's no question on that. Okay. I think your class did way better than the other class on matching on the motherboard. They didn't do as well as you guys did in that section. They also didn't get wrong like color on mouse wise. They all got that. Trying to think what else we need to go over. I'm not going to ask you the inches on the ATX motherboard. We do need to know that the ways to rate CPUs are the speed in gigahertz, what kind of cache and how much cache it has, and the number of cores on there. You should know what the difference between L1, L2, and L3 is. On the die, per die, off the die, per die, shared, right? Sometimes we'll see that as shared, but usually these are per die. So you'll see on a quad core, it'll say 32K×4. That's per die, and that one's shared. This is a quad core right here. That shows on the, I'm doing a memory scan before I take it to Austin's room, because he keeps blue screen and shut down, so I'm trying to make sure that everything works. You can see on this one, the L1 cache is only 32K. The L2 cache is 2 meg of L2 cache. There is no L3 cache on this one. Okay, and there's no hyper-threading on this one either. So it's four cores, four straight cores on that. But I've already gone through the test one. So let's see. he keeps blue screening. He's gone through 3 PCs this year, and he keeps blue screening. And so I went up before I take this one for a test. Okay, so there's no way, you can't just look at one of these things and say it's faster. That's why I like to use those charts where they've done lots of testing, because just because you have a higher speed, if you have a lower cache, the higher speed may be effectively slower. Does everybody understand that? It's going out more to the, if I've got low cache, it's going out to the system RAM more, which means it slows it down, even though the gigahertz of the CPU itself may be very fast. Now, we already talked about this, different using AMD and Intel. Intel's the LGA, AMD's the PGA, and you should be able to just look at a picture and say whether things go together. There's a couple of those just like there were on the motherboard. Some of the questions on this test, I expect you to look at and go, yes, that's the answer, without having to look at it, obviously. Some of them, you're going to have to go look at, and some of them it's going to be dependent on how much you have in your head at the time. Okay? So there are some that you have to look up. You have to follow links, you have to look up. But if I have a picture of a motherboard and that CPU, and I say, do these go together, yes or no, true or false, these go together, I'm not expecting you to look that up. I'm asking you, if you see AMD and you see an LGA slot, and you say no, and you move on. Okay? But you should know that by now. And I know that seems, at this point, almost trivial, hopefully, to you guys. That's like, well, that's a really easy question. But I don't know how many times people get further on the course and they're still matching the wrong processor with the, and I think sometimes people get hurried on presentations and they just don't look at the pictures, but at least I hope that, okay? So LGA is proprietary Intel slots, although we've seen that there are some AMD slots that are using, or AMD processors are using an LGA one now, and AM2, AM2 Plus, AM3 are proprietary AMD connectors. That's the picture of LGA. Make sure a ZIF socket or a PGA socket, and they always have a straight number or whatever I've seen. We talk about how the CPU has to stay cool, and I did show that one video in class with it pulling out, right? I only show that to the other class, I show it to your class. Chipset controls it, flow of information. Northbridge is faster because it does graphics and memory. Southbridge does everything else. And that's just a picture of the other side of the motherboard that everything's terminating at the CPU socket. But you can see it comes through the Northbridge here and then to the CPU on the way. And we talked about what's on the Northbridge, what's in Southbridge. Some people still pick the wrong ones at the Chapter 4 test. Only video memory have the North bus route through the North chipset, everything else is South bus route. And we talked about the different kind of slots extensively. Hopefully that's all easy for you guys. And we already talked about this. In fact, that slide was early on the thing. And we already know what kind of slide. So I'm going to show the video. I'm done with this. Anybody have any questions? Today.